Okay, so my first question on this one is, what's slightly different about 24 than the other ones you've done? What's slightly different, at least right now?
Well, it doesn't equal 0.
Doesn't equal 0. So on 24, it doesn't actually equal 0. So what do you need to actually... It doesn't actually have everything on one side, is another way to put it. So what do you need to do? Set it equal... Put it all on one side. So Newton's method helps you find where a function crosses the x-axis. So you actually want to find out where this thing right here... You want a solution to this. When this equals 0, it's the same thing as a solution to that right there. When this equals 0, it's the same thing as a solution to this. Do you agree with that? I put it on one side. I set it equal to 0. Okay, so if I'm going to attack this right here, what might be a small thing I can do to help me apply Newton's method to this? You could distribute the extra. That's great. So you have 4x squared minus 4x to the 4th, correct?
X to the 4th.
4x squared minus... Oh, there's no 4 there, is there? X to the 4th, correct. And what could I do to the other one?
Oh, turn it to negative.
Yeah. Why did we do that? Why is that helpful? Because we know we have to take the derivative, right. So what's that equation we have? We know that x, the next one, is equal to xn minus what? F of xn over f prime of xn. Is that like that? Does that make sense, everybody? Yeah. So what do we need to actually find? The derivative. Correct. We need to find the derivative. F prime of x. It's going to be what? 8x minus cubed plus 4 times plus 1 to the times 2x. Now, you can simplify this a little bit if you want to. F prime of x is equal to 8x minus 4x cubed plus what? 8x over x squared plus 1 to the what? Squared, right. Now here's the thing. We have our derivative, but what else does this call for? If we want to find xn, what's the question asking? It says, use Newton's method to find all roots of the equation correct to 8 decimal places. So you need to keep doing this until you don't move 8 decimal places down, until the decimal stops moving 8 decimal places down. So what do you actually need to start this, though? You need an x value to start with, right? You need an x1, right? You need an x1. That can be a little tricky, right? You said 2? Well, let's try 2. That's fine. Let's try 2 and see what happens. So we actually need to find f of 2 and f prime of 2. So let's do f of 2. F of 2 is going to be equal to 4 times 4 minus 4 minus 4 over what? 4 plus 1. So that equals negative 4/5. Are we already into fraction land? Do we really want to be in fraction land and do this by hand? No. So what can we use? Our calculator. Okay, so what do we do now? We do a similar thing, but instead of 2, what do we put in there? And now it's just going to be looped. Now, take a look at these decimals. We've done this a couple times. How many decimal places have stayed the same so far? Take a look. We want it to be how many decimal places?
8.
We want it to be 8. So we have 9, 9, 9. We have 4, 4, 4. Now we have 3 and 3. We have 8 and 8, right? So if this is correct to 4 decimal places, because we've done it and 4 have stayed the same. So let's do it again and see what happens. How many stayed the same? All of them. So did it get close pretty quick? Yeah, it did. So it got close pretty quick. So 8 decimal places right here. Now, we went and used our calculator when we got to here, because what do we not like about this? Fraction. We went and used this because we wanted to use our fraction, but we could tell that we were going to have to use our calculator. Why? Look what it says in the question. Approximate to 8 decimal places. Do you have any idea what you'd have to do in order to get this correct to 8 decimal places? A ton of division and fraction work, right? Let's assume you were perfect at it. Let's assume you made no errors. It would still be really, really hard. But what are you almost certainly going to do somewhere when you do 100 lines of this? You're going to make an error somewhere, and then it's not going to be correct, and you're going to end up with, like, all of a sudden you're going to be like 1.9, 1.945, 17. And you're not going to know where it came from. Okay, so, domain. What's the domain? All real numbers. Okay, so what do you want to go try to figure out next? Intercepts. So 0 is equal to x e to the negative x. So you know that 0 is equal to x over e to the x. That only happens when x is equal to 0. So you know one of the intercepts is 0, comma, 0. Are there going to be any others? No others. So it only crosses the x-axis once. It only crosses the y-axis once. At 0, 0. Nice. What do you want to try to find next? What do you want to try to find next? Symmetry. I like that. Symmetry. Is there any? No, there is none. Okay, so there's no symmetry, and we have this one intercept right here. Nice. What do you want to try to figure out next? Asymptotes. Okay. The limit as x goes to infinity of x e to the negative x. What's that going to be? 0. Right. So you know you have a horizontal asymptote where? Y equals. Okay, it equals 0. Kids, I'm having a conversation with myself here. You just figured it out for me. You told me very properly. It's 0. The horizontal asymptote is y equals 0 as x goes to infinity. As x gets infinitely big, this thing gets infinitely close to y equals 0. You just told me that. That's nice. What about this, though? What about the limit as x goes to negative infinity of x e to the negative x? What's that going to go to? It's going to go to negative infinity. Are you sure about that?
Yeah, because it's...
That's going to be negative, right?
Yeah.
And this is going to be infinitely big.
Yeah.
That it doesn't make it negative, it flips it over. Yeah. You're absolutely right. So, is there a horizontal asymptote the other way? No. So as x gets infinitely big, this thing gets close to the x-axis. But as x gets infinitely small, it goes down. So what is this thing going to look like? It's going to go towards the axis there, but then it's going to go down and to the left. As x gets infinitely negative, this thing is going to go down. So there's your end behavior right there. I'll call this end behavior. Okay, what do you want to try to find next? What do you want to try to find next? Intervals of increase and decrease. Good. So if we want to examine intervals of increase and decrease, we're going to need to look at the what? So we know f of x is equal to x e to the negative x. So what is f prime of x equal to? What do we have to use? So the derivative of the first times the second plus the first times the derivative of the second. So we're looking at e to the negative x minus x e to the negative x, and we want to know when that's equal to 0, because we're really interested in figuring out everything else, but we want to know when that's equal to 0. Exactly. Nice. So we know that e to the... What can we factor out of each of that? E to the negative x times 1 minus equals... Can this right here... What do you know about that? It never equals what? So you know that it's 1 minus x is equal to... So x is equal to 1. So your first derivative test right here, 1, there's the x value, and then the f prime value. What's f prime when x is equal to 1? You just figured it out. 0. So you want to know what the derivative is to the left and to the right. To the left of it, what is it? You already did this, so you should know. It's... You sure? It's positive. And what is it to the right? It's negative over here, yeah. You do it, you plug in the values, plug in... What could you plug in to the left of 1? Plug in 0. Plug in 0 into this, and what do you get? 1 minus 0. What's 1 minus 0? 1. Plug in something to the right, and you'll end up with something that's negative. Because you're going to end up with something minus more than one of it, right? 2 minus 3 times 2 is going to be negative. It's always going to be negative. You can also, it's easier just to look at this. E to the negative x is always going to be what? Always what? It's always positive, right? So 1 minus x, if x is greater than 1, is going to be negative. Okay, so we found where it's increasing and decreasing. What does that tell you about this point right here? What kind of point is that? If this function is only increasing and then it's decreasing, it's a max. That is not the point, that's the x value. So what should you find? The y value, exactly. So how do you find the y value? Well, you do f of 1, which is 1 e to the negative 1. So what's that? 1 over what? E. So you know you have a max at what? 1 comma 1 over e. So you just found out where it's increasing, where it's decreasing. Nice. You also just found out what the range is, by the way, because you just found the biggest value. What's the biggest output this thing can have? 1 over e. So what's the range of this function? Y such that y is less than or equal to what? 1 over e. 1 over e. It goes up to 1 over e and goes down. Can it ever get higher than this point? No, because it's going up to this point, and then what does it do?
Goes down.
Goes down. What's really interesting, though, we know this is going down, but it never can go below what?
0.
Well, actually, it could go below 0 and then come back up. Can you cross horizontal asymptotes? Yeah, you can. You can cross horizontal asymptotes. It is possible for the function to go down and then dip back up. But for a function to go down and then up, the derivative has to be 0 somewhere, right? Is the derivative 0 anywhere else? No. So with that information, we know it doesn't. Okay, so we know where it's increasing and decreasing. What's the last major thing we need to check? Concavity. Concavity, concavity. So what are we going to look at to examine concavity? Second derivative. We knew that f prime of x was equal to what? E to the negative x times 1 minus x. So f double prime, let's use the product rule on that. I like using the product rule on that. The derivative of the first times the second plus the first times the derivative of the second, which is what in this case? Negative 1. So what do you end up with? Negative e to the negative x times 1 minus x minus e to the negative x. What can you, and we want to know when that's equal to 0, because we really want to know what the sign is everywhere else. What can we factor out of both of those? How about negative e to the negative x times 1 minus x plus what? Plus 1. Are we okay with that? We want to know when that's equal to what? Well, we know that this right here is never equal to. So we're looking at what instead? 2 minus x is equal to. So x is equal to. Now that's the place where the second derivative is 0. So what do we need to test on either side? Is this positive or negative? We need to test the sign. So x and f double prime of x. It was negative e to the negative x, 2 minus x, and the product. What number is really, what's a great number to the left of 2? 0. What's this one going to be? 0, 2. If you multiply together, it's not going to be helpful, right? Oh, wait. What's the problem? Whoops. So what's the product come out to be? Positive or negative? Why? Oh, it is negative 1, isn't it? Because there's a negative out front. Right. We got to be really careful. Wow. Together, we're doing okay. Any one of us not doing okay right now. Okay. So what's the product come out to be? Negative. Okay, so then let's plug in a 3 here. Is it negative or positive? Negative. That thing is always going to be negative, actually. And this is going to be negative, so it's going to be... So what happens at x equals 2? What happens at x equals 2? Changes concavity. Changes concavity. So we know it's concave up where? Where is it concave up? Smiley. What is it? 2... infinity, and we know it's concave down where? To 2, exactly. So we now know it occurs at x equals 2, but what should we also find? It's not x equals 2 is not a point. What else do we need? Y value. We need to totally describe that point. So again, what's our function? F of 2 is going to be, is it negative e? What is it? It's 2e to the, so that's 2 over. So we have, what do you call this? Yeah, this is an inflection point. Do you now have a ton of information? Yeah, you have a ton of information. What is this thing going to look like? Well, where do we know it crosses? What's that one intercept we know? We know it crosses here. And then we know that there is a highest point when x equals 1, right? When x equals 1. When x equals 1, what's that highest point equal to? 1 over e, right? So we know it's increasing and it's concave down up until that point. Actually, it's concave down all the way until what? 2, right? So we want to do a 2 right here, and it's, what's the other? It's 2 over e squared, which is, it's actually less than 1 over e. So it's like right here. It's not halfway. So it's right about here. So what does this function do? It goes up like this and down. You see how that's still concave down the entire time? But it's on this time, does it go up again? No. What does it do? It continues to go down. But what does it not cross? Because the only places, we already know it only crosses the x-axis at the origin. So The best way to do this, actually, you could label it. You could also just do this. You could say that point right there is 1 comma 1 over e. And what's this one? 2 comma 2 over e squared. The only thing here that's a little hard to logic out is the relative value of 1 over e compared to 2 over e squared. That's the only thing you can think of. But you should be able to figure out it's less than it if you think about it in terms of like e is about, if you round it to 3, like 1/3 as opposed to 2/9. You can round it a little bit. Also, you know it has to be below because if you're confident in your derivative, you know from here on the graph is going down. So it better be below 1 over e. It better be below 1 over e. And we also proved that it's a maximum. So we have a lot.